Hi there everybody. In this video I'm going to be taking you through my review of this. This is the new EMAX Hawk Apex 3.5 inch bind and fly. And in this video we're going to be looking at some flight footage. I'm going to be taking you through the key features of the quad on the bench, as well as a black box log analysis and PID tune for the quad as well. If at any point in this video you decide that you'd like to try one of these out for yourself, there are links down in the video description to where you can order yours today, and they are affiliate links, which means that if you do use them and then buy anything from the affiliated retailer, it helps support the channel a little bit, and it doesn't cost you anything either. EMAX have sent me this quad free of charge for my review, but they've had no other control over the content. That said, let's get on to the review. Let's start by looking at some flight footage. And this quad runs the HD0 25mm VTX along with the HD0 Nano camera. And I think the HD0 Nano camera is doing a really good job here. The colors are really nice, there's lots of detail and clarity in the image, and it's a really nice looking image as well, particularly on a sunny day like today. I've only got the VTX set to 25 milliwatts because I'm flying the quad exactly as it was delivered to me. Stock tune, stock filters, PIDs, everything. So you will see some sparkles as we go behind these trees, and that's obviously a trade-off for the constant latency that the HD0 system provides. In terms of how the quad handles, there is a bit of prop wash on sharp moves, and I do notice some jello in the video footage at certain throttle positions. We need to take a look at a black box log analysis to see if that's a frame resonance or whether it's something to do maybe with the TPU camera mount. But there is a little bit of prop wash, a little bit of jello, and the rates are set very low, which is much more suitable for racing than for freestyle. Overall, the quad flies well, and so let's take it over to the bench and have a look at the key features of the design. Alright, so let's take a look at this new EMAX Hawk Apex on the bench. So in the box we get some stickers, QR code for the manuals and support, a disclaimer, don't need that. And as to the drone itself, we get this, I've got the 3.5 inch version here, although there is a 5 inch version available as well. Both the 3.5 and the 5 inch version use the same motors, these 2004 motors with different kV, depending on the size of the drone and also what battery voltage you select. The 5 inch version is available in 4S or 6S. The 3.5 inch version is only 4S compatible. We also get a little bag of screws and 6 of the new EMAX Avia Props, which we'll talk about later. Okay, so let's look through this model in more detail. Start with the frame. This frame is an interesting construction. It's got a boomerang style front and rear arms. So it's a single piece of carbon for the 2 rear arms and a single piece of carbon for the front arms. Then in the middle here, you've got 2 thin plates which kind of sandwich together and capture this battery strap. And there's lots of engraving and cutouts on the arms here, I guess to save a bit of weight and also to provide an inlay so that the middle part of the frame can kind of lock into the lower part. Press nuts on the top to secure the arms, and then 4 screws that come through which capture this battery strap. So if you want to remove the battery strap, you're probably going to need to take off these 4 screws. The battery strap is really tightly captured in there. The top plate looks to be the same thickness, and again it's got quite a lot of this engraving with a mount here for a 25mm board that's not being used and a 20x20 mount. So it's interesting there that the bottom plate and top plate both seem to have mountings for flight control stacks. The electronics is all mounted on the bottom plate. The F7 AIO flight controller is in the bottom of the stack, and then we've got the HD0 25mm board on top. And then the ELRS receiver looks to be mounted inside a little 3D printed holder here that's coming off of the standoffs. There are 4 standoffs, 2 front, 2 rear, and they have a 3D printed mount for the Express LRS receiver on this bind and fly version. You can also get it plug and play as well. And then this is the antenna for the HD0 VTX. So they're using the 25mm HD0 board, so 200 milliwatts of max output power. So this is very much designed for sort of relatively close proximity flying, racing, where you're not going too far. You don't need to punch through a lot of walls, anything like that. The camera on the front is the HD0 nano camera. So I'm very interested to see how that looks when we get out to the field and fly it. HD0 typically make the best cameras for their system. Better than the cameras that we've seen from the likes of RunCam. So it'll be interesting to see how that compares. The motors on this build are an interesting choice. They're 2004 3000 kV. And 2004 is a really big motor for a 3.5 inch quad. And it's a relatively small motor for a 5-inch quad. So it's interesting that they've done 2 versions of the Hawk Apex, 3.5 and 5-inch, with the same size motor, different KVs, but the same size motor, these EMAX Eco 2 2004s. The motors, I think, end up being a little bit oversized maybe on the 3.5-inch and a little bit undersized on the 5-inch, but let's see how they perform in flight. Let's take a moment to talk about durability. The arms on this quad are 3.5mm thick at the thickest point, and this front strut here has been thinned down by engraving to 2.5mm thick. Now this is a little bit thinner than what we've seen on some other 3.5-inch quads, which tend to have arms that are 4mm thick. I've had a bit of a crash with this quad. It was not a particularly hard hit. I mean, the motor wasn't damaged, but I have managed to break the arm, crack this front strut in 2 places, and snap the main strut as well. Now I think if you're racing this quad quite hard, it is likely that at some stage you're going to break an arm, and I think replacing the arms is going to be a little bit more tricky than on a design with separate arms. You're going to have to remove 1, 2, 3, 4, 5 screws minimum, and the other motor on the other side, and then take this whole boomerang section out and replace it. Hopefully you can get these arms as spares, because you're probably going to need a few of them if you're racing the quad often, just given the nature of the arm, and it's relatively thin, both thin in thickness but also quite narrow in section here. So that is going to make the arm more prone to breaking in hard crashes. Let's take a look at a video of that hit, and then obviously you can decide for yourself whether the quad should have survived that hit or not. So here's a video of the crash. It's quite a straightforward one really. I'm just dropping down out of a split S and I'm not used to the rates, and I misjudge it and I hit a metal beam. The battery does eject from the quad and I lose video, as well as obviously causing the damage that I showed you on the arm. So let's take a quick look at the weight now. I'll just pop this on the scale. The build dry comes in at 173 grams, and with an 850 milliamp hour 4S, it's actually coming in at 270 grams. So already over the 250 gram limit. And if you did want to add a naked GoPro or something like that, you'd be looking at around 315 grams. You might be able to squeeze this under 250 grams with a smaller battery. So if you went with something like a 550 or maybe a 650 milliamp hour, you could get it just under 250 grams. But these larger motors are bringing the weight up significantly. EMAX have launched a new prop with this drone, and this is the EMAX Avia 3.5-inch prop. And if we compare it to the previous 3.5-inch prop from EMAX, the Avon Scimitar, we can see that there are some pretty notable differences. The Avia has a much wider chord and a much steeper pitch than the Avon prop. And that's going to give it a lot more thrust, a lot more top-end speed, but it's also going to give worse prop wash handling, and it's going to require a lot more torque from the motor to drive it. Steeper pitch props are also typically less efficient, so you will see a penalty in flight time from flying a prop like this. But you can see from the design that EMAX are intending this prop more for top speed and racing rather than flight time and efficiency. If you're interested to see how these two props compare against each other on the thrust stand, as well as how they compare against a whole bunch of other 3 and 3.5 inch props, make sure you're subscribed to the channel because I'm planning a shootout for props of this size on the test stand in the near future. Now that we've looked at the design of the quad in detail, let's dive into the Betaflight configuration that the quad ships with. Okay, so let's take a look through the Betaflight configuration for this drone. And first off, looks like we are running 4.3.0, which is good. So it's running the latest Betaflight. Let's take a look at the configuration. 4 kilohertz PID loop frequency. What gyro are they running on this? Okay, they are running an MPU 6000 gyro and an F7 flight controller. So there is no reason why you would not be running 8K on this. So we'll go ahead and set 8K. Arm angle 180, good. Dshot beacon is enabled, but not set to beep if it loses signal. So if you fail safe and your quad gets lost in some long grass, it won't beep to tell you where it is. So we'll turn that on. And I like to set it to tone 3 because I find that's easier to hear than tone 1. Tone 1's a little low. Everything else looks sensible. Telemetry, air mode, OSD, all good. Let's take a look at the PID tune. We'll start with the filters. So they've moved the sliders up. So they've reduced the filtering a little from default. 5 notches on the dynamic notch. That's 4 too many. So you're going to be adding some delay with that. And also no RPM filtering. Okay, I mean, that's a key feature. So we're going to need to get RPM filtering working. I'm going to turn the dynamic notches down to 1 in anticipation of enabling RPM filtering. And I'm also going to disable all these gyro filters because we won't need those. Yeah, okay. Let's look at the PID profile. So they've got a custom PID tune. They've turned the D gains down, they've turned the P&I gains down, and they've then turned the master up. This doesn't make a lot of sense to me. If we were to set the, so we're at 44, 95, 39. If we set that back to 1, and that back to 1, and that back to 1, we're at pretty much exactly the same position we were in at 0.85, 0.9, 1.1. Yeah, when you're tuning a quad, don't use this damping slider and the master multiplier and the P&I slider. If you're using all of them and you're moving them all in different directions, you're probably cancelling out what you're doing. I tend to leave the D-gain slider at 1 and then only adjust the master multiplier to change the D-gain. And then I change the P&I slider to adjust the balance. But we can just leave all these at 1.0 and that's absolutely fine. And feed forward, we can bump up a little more because we've turned the master down. Dynamic damping and I gains can be left. We can check all that in logging. Can we check all that in logging? No. Okay, so this flight controller doesn't have Blackbox logging. So that's a real miss there because every flight controller, it's 2022. Every flight controller should have a Blackbox log chip or an SD card slot at least for Blackbox logging. If you don't have a Blackbox chip on your flight controller, you better hope that it flies absolutely perfectly the first time that you fly it and every subsequent time. Because if there's ever an issue, there's nothing you can do to fix it because you won't know what the problem is because you haven't got logging. And no one will be able to help you either because you don't have a log to show them what's going on. So that's going to be a problem. It's either going to fly perfectly well. I'm sure it will fly fine, but you will never be able to push the tune as far as you would want. You'll never be able to fix any issues. You're just stuck with it how it is. On the motors tab, Dshot 600. So that again doesn't make sense why you'd run the PID loop at 4K and Dshot 600. You'd use Dshot 300 if you were running at 4K, or more likely Dshot 600 and 8K. And bidirectional Dshot is not enabled. We want to enable it. We may need to change the ESC firmware if we want to do that. We can check that. Okay, but that pretty much covers it for the Betaflight configuration. I'll leave a diff of my Betaflight configuration for this quad when I finish with it. There'll be a link in the video description for that. Okay, so to enable bidirectional Dshot, we're going to need to update the ESC firmware, most likely, and I like to use BlueJ. So let's get connected and plug the ESC in. And read the settings. Okay, so it's running BLHES 16.7, so that doesn't support bidirectional Dshot as far as I'm aware. So we're going to update this to BlueJ. Flash all ESCs, BlueJ, version 0.16, and PWM frequency 48. It's always a good one for a quad this sort of size. 48 is good for smaller quads, up to maybe 5-inch. And then for larger, I would go maybe 24 for like 7-inch rigs. Okay, and all of the default settings for BlueJ are pretty good for quads of this size, so I wouldn't touch them, just leave them alone. You even get a nicer startup sound. If we jump back into Betaflight Configurator, we can just make sure that bidirectional Dshot is enabled and that we now have RPM filtering, 3 RPM filters with 100 Hz minimum frequency, dynamic notch filter of 1. Jump up into the Setup tab. The way to check that RPM filtering is working is to unplug your flight controller, plug it back in, and in the Setup tab you should see RPM filter as an arming disable flag here. If I now plug in the battery, RPM filter goes away, and that shows that it's working correctly. You can also check the error rate on the motors, and without props on, you can even spin the motors a little bit and check that you can see the RPM data coming through. So now that we've looked at the Betaflight configuration, let's jump into a Blackbox log analysis for this build and see how it performs from a vibration perspective. We'll start by looking at the gyro scaled axis on roll. And you might remember that this flight controller doesn't have a Blackbox chip, so I've had to add an OpenLager serial logging device to capture these logs. Overall, there are frame resonances at 180 Hz, a relatively sharp one there, another one at about 300, and we see some what could be a resonance or could be just a lot of broadband motor noise up at around 400 Hz. And that's all fine, that's kind of what we'd expect to see. What is a bit surprising is all of this low frequency noise up to about 75 Hz. That is almost certainly the cause of the jello that we're seeing in the FPV feed, because the camera is going to be very, very sensitive to vibrations at these low frequencies. So let's jump into the frequency versus throttle plot and see what we can see there. And immediately what jumps out to me is that this low frequency noise is at about 40 to 60% throttle. And that's where I was seeing the jello in the FPV footage when I was flying the drone. So we can be pretty confident that this low frequency noise is the cause of that jello. And we can also see that it seems to be being excited by this higher frequency noise at 400 Hz. We have this big bright section here, lots of motor noise at that higher throttle position. And that's kind of being referred down and creating low frequency noise. Now, normally when I see this kind of low frequency noise, particularly when it's getting excited at higher throttle positions, that is typically due to flexible components on the quad. So maybe the TPU camera mount, maybe the TPU ELRS mount that they've got on the build, that's starting to vibrate at these lower frequencies when there's kind of enough vibrational energy in the whole system from the motors being at a high enough throttle. So if you're looking to resolve that jello, you could try maybe changing out the receiver mount, using something that's a bit shorter, a bit stiffer, or potentially moving to a stiffer camera mount, one that's not made of TPU. If we look now at the pitch axis, we can see that we don't have any particularly sharp frame resonances until about 300 Hz, which is really good, but that we again do see quite a high noise floor at low frequencies. So the noise isn't really coming down very quickly, and we've got quite a bit of noise up to, again, around maybe 75, 80 Hz. If we go and look in the frequency versus throttle plot again, we kind of see the same story. It's very quiet down here at low throttle, but then as we increase the throttle, all of those flexible components start to vibrate around, and you get this kind of broadband diffuse noise. We can also see the couple of frame resonances on pitch here that are getting excited by the motor band, but these are at pretty high frequencies, 320 and 370-ish Hertz, so they're going to be well filtered out by the filters in Betaflight. It's this low frequency noise down here which is going to cause us a problem. We can't really filter it out, and it can be visible in the FPV feed. And finally, looking at the yaw axis, we're again seeing a similar story to what we saw on pitch and roll, which is a relatively high noise floor at low frequencies. And again, if we jump to the frequency versus throttle plot, we again see it's nice and quiet at low throttle, but then as we ramp the motors up to a higher RPM, we do start seeing a lot of noise at low frequencies as those flexible components start to move around a little bit. And this is something that you might see with other bind and flies that have lots of flexible antenna mounts and things like that. So if you do see that in your logs, then that's a good pointer to what might be the cause of that. And if you can remove those flexible components or stiffen up the mounting in some way, you should see an improvement there. All right, so that brings me to the conclusion section of this video, and I'll tell you what I think about this EMAX Hawk Apex 3.5. Let's start with the things that I really like about the build. The video system on this quad is excellent. The HD0 nano camera looks fantastic, and the HD0 VTX, okay, it's only 200 milliwatts, so you're not going to be punching through walls or anything like that. You're going to need to fly relatively close to yourself, and if you go too far or you go behind too heavy objects, you're going to start to lose video. But at 200 milliwatts, it's perfectly good for flying close to yourself and ideal for racing as well. The build of the quad overall was really neat. The quality was good. All the solder joints were fine. And the quad flew really well, I think, out of the box. Although the tune was on the conservative side, which might be fine for racing, but for freestyle, I'd look for something just a little bit tighter and more aggressive with a bit less prop wash. Now let's come on to some things that I think could be improved about the design. I think the 3.5mm thick bottom plate is a little bit thin for a 3.5 inch quad, particularly with motors this heavy. I found it a little bit fragile. Obviously I broke an arm, and if you do need to replace the arms, it's quite a faff to do it. And thinning down the front strut of this arm also is, I think, a bit of a miss, because this is already a very thin section, and to thin it down even more, makes it easier to break it. If you do pick up this quad, just make sure to pick up a bunch of spare arms. I hope they're going to be available, because you are going to need to sort of keep the quad maintained and replace those if you do crash hard and break an arm. The TPU antenna mount at the back for the ELRS receiver, in my opinion, is a little bit too long and a little bit too flexible, and is very likely to be responsible for the jello that I was seeing in the FPV camera feed. So I would look to design something quite a bit shorter than what they've got here, and a little bit stiffer, so that you don't get all those all that jello and all those low frequency vibrations at high throttle. The flight controller, F7 flight controller and MPU 6000 gyro. So great combination. That's what I really like to see. We know that's a good gyro, it's proven, and an F7 flight controller is going to give you plenty of performance for running all of the filtering on Betaflight. Strange that it's set to 4K, that doesn't make a lot of sense. Strange that RPM filtering isn't enabled, because it really should be. And also a big miss that there's no Blackbox logging on board, and that I had to add this extra Blackbox logging component chip there to be able to log to an SD card over the serial interface. The fact that the flight controller does have some spare serial ports is good, because that meant that I was able to plug that in. But really, just having a Blackbox chip on the quad itself is a better solution for most people most of the time. So I'd hope that, in the next iteration of this flight controller, they can look to add a little Blackbox chip, even if it's only 8 or 16 megabytes. Even a small amount of Blackbox space really, really goes a long way. The motors on the quad, I really like the EMAX Eco 2 motors. I think they're great value and they're very well made. 2004 is a little on the big side for a quad that's only got 3.5 inch props to spin. So these would be suitable for a 3.5 inch Cinewhoop that's much, much heavier and running at much higher throttle more of the time. But for racing, if you're always at very, very high throttle, then 2004, those motors are going to stay nice and cool. You could possibly get a little bit of a longer flight time with a bit of a smaller motor, but that's just a trade-off that they've made. And I think that for a quad that's designed for racing, a larger motor, more powerful motor is going to be good. So the final thing to talk about is, who is this quad for? So who would this be the ideal quad for? Well, it flies really well out of the box, but it doesn't really have features for kind of tuning. So if you're just looking for a quad that's going to be very easy to just pick up and go fly, then this definitely fits the bill for that. It's set up for racing in terms of it's got racing rates, and the PID tune and filter tune that's on there is more suitable for racing. It's a little bit on the fragile side though, perhaps for a racing quad. So if you are going to be racing this a lot, make sure to have several of these quads and lots of spare arms, because I think if you start hitting race gates, you're going to break these thin struts on the front quite quickly, and you're going to want to be able to replace those easily. It's a great quad if you're all in on HD0 and you love that video system and you just want to bind and fly that's all set up for that, and you're going to get really, really nice image quality with all the benefits of HD0 like Betaflight canvas mode and all of that stuff. I really hope you enjoyed this really in-depth review of this bind and fly, and that you found all the information in this video useful. If you've decided that this bind and fly is right for you, there are links in the video description to where you can pick one up, and they're affiliate links, which means that they help support the channel. When you follow the link and buy any product from the affiliated vendor, I receive a small commission, and it helps support the channel and doesn't cost you anything. So please consider using that if you're looking to buy anything from EMAX or any of the other retailers I list with links down below. If you'd like to support the channel more directly, I do have a Patreon and a Buy Me a Coffee, and there are links in the video description to those as well. And I really appreciate all the support that I receive from the community that helps me continue to make these videos. That's all I have for you for today. So until next time, I wish you all very, very happy flying.